So welcome back, everybody. I'm going to welcome you back, and I'm going to introduce you to Dr. John Harding from the Western College of Veterinary Medicine. John, after graduating from the Ontario Veterinary College at the University of Guelph in 1988, Dr. Harding worked in a mixed animal practice in rural Saskatchewan. Since 1991, he has specialized in pork production, and I thank him for that as a Mennonite and a major pork eater. And in 1997, established a swine consultancy practice. In 1997, he also completed his Master's of Science degree in veterinary medicine at the University of Minnesota. He is a diplomat of the American Board of Veterinary Practitioners in the swine health management specialty. Now a full-time professor a full professor at the Western College of Veterinary Medicine at the University of Saskatchewan. He and his team of technicians, graduate students, postdoctoral fellows, and collaborators conduct research in swine diseases. Current research interests include swine dysentery, reproductive PRRS, and host genomic resilience to major swine diseases. Dr. Harding is the Scientific Program Chair of the Western Canadian Association of Swine Veterinarians, the WCASV, and is a member of the Prairie Swine Center Board of Directors and the Canadian Western Swine Health Intelligence Network. He teaches veterinary students swine production medicine in all undergraduate years. Dr. Harding worked in the pork industry for 16 years prior to academia. His interests outside of work include numerous outdoor activities and woodworking. With that, I'd like to thank Dr. Harding for joining us today and welcome him to start his presentation.
Thanks very much, Matt. I appreciate the introduction and the opportunity to speak with you today, and I hope you can hear me and just interrupt if something goes astray. So today my presentation is African swine fever and why it matters to Canada, and this is a really interesting story. In fact, it reads like a good mystery novel. There's a villain and a victim and a bunch of bystanders and some twists in plot. But on a more technical basis, though, it's very interesting in that it's really looking at the interface of agriculture, the environment, and wildlife, and it certainly has socioeconomic impacts around the world. Certainly has the ability to devastate many pigs as well as devastate very many businesses and livelihoods as well. So let's get going. So African swine fever virus, it's a member of the Asfarviridae, and that stands for African swine fever and related viruses. And in fact, it's the only virus in this family, which is quite surprising why we have it called and related viruses, because there are none. More importantly, though, there are 24 genotypes, so different kind of subgroupings of this virus, and the virulence or the ability to cause disease varies with each one of them. Of those 24, the ones that we are most interested in are in fact genotype 1 and genotype 2, and we'll get into that a little bit later. Other interesting bits of information, it's the largest double-stranded DNA virus. It's very stable and resistant in the environment. So for instance, 6 years at 5 degrees. So high tenacity in the environment, and that is in part related to why it's such a global threat. We'll talk a bit about that later. It's also the only known arthropod-borne DNA virus. The soft tick is involved in the transmission cycle, and we'll talk a bit about that. And pigs are the only hosts, which is a good thing. And I guess the other silver lining with this is that it's a non-zoonotic disease, so humans are not at all susceptible. The disease caused by African swine fever is termed hemorrhagic fever. So think of the worst here. After infecting the animal, the virus infects the lymphoid system and bone marrow, replicates in those tissues, and then it really does 3 to 4 different things. One of the most important things it does is cause endothelial cell death and vascular injury. So it destroys individual cells that are part of the blood vessel walls. And in doing that, punching holes through those blood vessels, it causes a bunch of vascular permeability, so we get leakage of fluid out into tissues. And that's what this picture down here in the bottom right is showing. This is a liver, so it's a pig, and the carcass has been opened up, showing the abdomen here. So this is the liver, and you can see this straw-colored fluid down here, which is leaking out of many different organs. But not only does it punch holes in vessel walls, but it also consumes a lot of the blood products that are used to clot. And as a result of that, you end up with this edema or fluid accumulation and hemorrhage everywhere else. Now, the other thing it does, kind of related to that, is cause what we call a severe thrombocytopenia. So thrombocytes are the precursor cell for platelets, and platelets are involved in the clotting system. They're small cells, they're very thin-walled, and their purpose is to, rub against areas of vascular injury, break open, and then the contents of those cells will be used to help start to form clots to patch the injury in that cell. And what this disease does is destroy the thrombocytes, so we end up with low numbers of platelets. So between the thrombocytopenia and this vascular injury, we then have all sorts of hemorrhages as well. And those hemorrhages are generally very small. We call those petechial hemorrhages, and sometimes they coalesce, and we call them ecchymotic hemorrhages. And I got some pictures here coming up in a few slides. Now, these are very acute lesions here. So these would be within the first couple of days. If the pig survives that stage, which is usually not very likely, then what the virus does is destroy the immune system, or what's left of it. So it causes destruction of dendritic cells. Dendritic cells are very important cells in the immune system that are involved with recognition of foreign antigens. So it wipes them out, wipes out many of the other responder or effector cells. It causes this leukopenia, which is a drop in all white blood cells. And then thirdly and lastly, it prevents the body from mounting a normal serum neutralization response, which would, for most viruses, is used as part of the way to sterilize the body or eliminate virus from the body. So it really just kind of effectively wipes out the immune system, in addition to causing this vascular injury. Now, if you're a pregnant female and the virus does cross the placenta, kills fetuses, and causes abortion as well. And again, this would be if you survived. So now this is a pretty bleak picture that I'm painting, and I must admit, it doesn't happen all the time. So there are these 24 different genotypes, and there's many strains within these genotypes. And this picture I'm painting would be the black and white case of very, very severe. But in a lot of times we have less severe strains. So in that case, the immune system would be reduced but not wiped out completely. There would be some dendritic cells that are affected. But one thing that's inherent to all of the African swine fever strains is that there is this lack of serum neutralization response. So here's some pictures. Let's start off with the foot here. Everybody should recognize that. You can see it's got some, red staining here. Well, that's the hemorrhages that are part of this vascular injury. Some of them are very, very small here. They're almost petechial. This carcass, kind of the belly of this pig here that's on this table, shows these nice little petechial hemorrhages, very nice, and then they're coalescing kind of at the back end. Here's a pig here. I think that this pig belongs to this foot here, and you can see his ears are affected as well. And then we've got this pig here that has these lesions, red lesions, hemorrhagic lesions on its back end as well. And this pig has a bit of a diarrhea. Now, as we work inside, those hemorrhages are present on just about all surfaces. This is the back of the throat, or the epiglottis. This portion right here, and these red spots are these petechial hemorrhages. Here's more of the same. So this is a kidney, and the term we use for this kidney is called turkey egg kidney. When I went to school, we were warned that that is a classic sign of either classic or African swine fever, and to be very aware. And we know now that this lesion is caused by more than those diseases, but it is pretty unique. Here's an intestinal or in the intestines here, there's small intestines, and we see the outside surface of the serosa has lots of petechiation. And then this is another very interesting lesion here in the top right-hand corner. This is the hard palate of the pig. So we're looking at the bottom surface of the upper jaw, and this is the tonsillar tissue here, which is just kind of the end of the hard palate, more like the soft palate in the pig. And these areas of yellow, blebs that are sitting here, that's what we call tonsillar necrosis, and that's a key lesion that's seen in several different of the foreign animal diseases, but including African swine fever. And then the other thing that this virus does is cause hemorrhagic lymph nodes. And these pictures that I'm showing here show some of those hemorrhagic lymph nodes. So this is an intestine here. So these are the mesenteric lymph nodes, and they're usually white to creamy pale to tan in color, and these guys are deeply hemorrhagic. In the bottom left here, this is the stomach that we're seeing with the duodenum, and then these are what we call the gastric hepatic lymph nodes. And they're usually so small we don't even see them, and they're deeply black here and quite enlarged. And then there's another inguinal lymph node up here in this picture in the top right. And along with this picture, there's some fluid that's in the abdomen as well. So just wanted to give you just kind of a rundown of what the disease looked like. And I apologize that it's right after lunch and you're probably not thinking this is the best things, but that is the end of the gory pictures, or at least most of them. So we'll turn our attention now to kind of an overview of more clinical signs, because I've talked about the acute stage and the peracute stage, which is very, very severe. But the other thing to keep in mind is that we sometimes have pigs that survive and move into subacute and then into chronic phases where the mortality is much lower, in addition to the fact that we have these different strains that sometimes don't cause severe disease as others. So it can be murky, although we would hope that in a Canadian farm, if affected, we would have clinical signs that were distinguishable, at least that traditionally we had hoped that. But for reasons that we'll explain later in the presentation, I think we may be dreaming, or at least very fortunate if that's the case in Canada. So why is this all relevant to the Canadian industry? Well, I guess, first, this is a foreign animal disease, which means it's not present in Canadian pigs, whether those are wild pigs or domestic pigs. We don't have this disease, and in fact, it's not even in the Americas at this point in time. So it's over across the ocean in Europe and Africa. But as we saw with PED virus, or porcine epidemic diarrhea, it can come here pretty quick. So I think we are obviously very concerned and doing everything we can to keep it out of the country. If a pig was infected or a farm was infected, it would elicit a CFIE response. This disease, in a matter of a decade, or I guess it's up to 14 years now, has emerged to become the most significant global threat to the swine industry in the world. We used to think that was PRRS virus, but now African swine fever and PED, but this one is far more severe than PED is. So this has the potential to kill 50 to 70% of the pigs in the world, the commercial pigs in the world, and the estimates that I've got is approaching 50% at this point in time. It disrupts farms, businesses, communities, livelihoods. In Canada, it would immediately shut our borders to trade, and in this case, we would have a lot of pigs that need to find homes. And unfortunately, at this point in time, there's no vaccine available for African swine fever anywhere in the world that has been registered, although there's a number of vaccines that are being used or developed, and there's one, in fact, that's being beta tested in Vietnam, and we'll talk about that in a few minutes here. So just to emphasize how devastating this disease can be, this is a news clip from November of 2019, and I'll just read what it says here. I got to look to my other screen, though, where it's a bit bigger. A quarter of the world's domestic pigs have died this year as the virus rampages across Eurasia, and that may be just the start. Half of the pigs are in China, which last year numbered 440 million, some 50% of the pigs in the world. So this is a very, very severe disease, and this is a picture of disposal of carcasses in trenches that have been dug, and in this case are lined as well to try to keep the virus in. So now let's turn our attention to the transmission cycle, and I guess how this emerged from a sleepy disease in Africa that nobody seemed to care much about 10, 20 years ago into, the disease that, has potential to wipe out the pig industries worldwide. So it is an endemic disease in sub-Saharan Africa, and it lives in three different types of wild pigs in Africa, the bush pig, the giant forest pig, and the warthog. And what's very interesting is those three pig species are in fact resistant to the virus, or they're resistant to the disease, meaning they become infected, but they do not show any clinical signs. And in fact, transmission, pig-to-pig direct transmission, through either oral secretions or nasal secretions or through feces is very inefficient. And in fact, the virus requires a third party, and that's where the soft tick comes in. And this tick essentially is a blood-sucking tick, so it bites and then it transmits between its pig hosts as it feeds on various pigs. So periodically it spills over into domestic pigs, and in fact that's how this virus was discovered in Kenya in 1921, because when it jumps to domestic pigs they have a near 100% mortality. So that's where the initial outbreaks were discovered, and then this virus was subsequently characterized. So as long as the disease has been in the wild pig population and circulating there with these ticks, everybody was happy. There have been 3 incursions, though, outside of Africa in the last 50 years. So the first one was in 1958 into Lisbon. And we'll talk about how that happened in general, how this virus moves around, because it does use a couple of different modes. The second incursion was 1960 to 1986, and that's when it moved from Africa into Western Europe. Several countries there, so Portugal, Spain, France, Italy, Sardinia, keep that one in mind, Malta, Belgium, and the Netherlands. And then it jumped to Latin and South America. And Latin and South America are as close to North America as it has ever come. These were all genotype 1 virus incursions, and all except Sardinia eradicated the virus completely by 1995. And the reason that Sardinia didn't is because it has a soft tick population. And that, in theory, could be important for Canada as well. That to this day, Sardinia and the wild pig population is still endemically infected. So in Latin America, which is the closest it's come to the North America markets of Mexico, Brazil, and Canada, this is the years that those countries were infected. This is the number of culled pigs, so 1.23 million pigs in total, and over 840 outbreaks reported in those countries. And obviously, pork is a staple protein source in some of those countries, so it was clearly pretty devastating, but thankfully they did eliminate. So where that leaves us, though, is to the incursion that we are presently experiencing, and this one is different in that it is a genotype 2 incursion. It's also very, very severe, and this started in 2007, where the virus jumped from Africa into the Caucasian region, specifically in the Republic of Georgia. And then it spread east to Russia, Ukraine, Belarus, and then over on the western side to Poland, and then has jumped into Central Europe. So Belgium was infected, now eradicated. And then the virus moved to China and then through Southeast Asia as well. So it has really spread quite dramatically, and I'll take you through some of those details here in a few minutes. So genotype 2, as I said, it jumped to the Republic of Georgia at the port of Poti. It's thought to have been brought there by garbage that originated in Africa and ended up at the port and then was subsequently fed to pigs. As you can imagine, Pork production in Eastern Europe is pretty extensive, with lots of small-scale production, pigs in the backyard. So any food source, and pigs will eat anything, obviously, any food source is welcome to those farmers. So port from the garbage from the port ended up on a pig farm, and then it was transmitted amongst pig farms through either lack of biosecurity, so people visiting or moving pigs, or in some cases where certain countries were infected, the price of pork collapsed, and then that meat found itself being exported to other countries who were looking for a cheap source of pork. So obviously socioeconomic class kind of falls into this whole mixture of how this virus moves around. Most of those countries now in Eastern Europe and over into Russia then remain positive. So what's very interesting about this virus is that there are 4 different transmission cycles. So we'll go through each of these, but the first cycle involves the wild pigs in Africa and the soft tick that we've already talked about. And then the second transmission cycle is the spillover effect of that wild pig into the domestic pig population. Now that would primarily be in Africa for cycle 1 and cycle 2, the exception being Sardinia. But how it jumps around the world in these large-scale jumps is by pork product. So that would be infected pigs, and then their product or byproduct ends up being transported by ship, by air, by persons, or it could be live pigs that are moved between places, farms or countries, in some instances through either just trade of pigs or through slaughter. So that is this movement of pork and pork products that forms the third transmission cycle. And then very interesting and unique to African swine fever is the fourth transmission cycle, and that's where wild swine come in. And we particularly mean the Eurasian wild boar, which is endemic throughout most countries in Europe, but has the potential to be also a problem in North America because we have vibrant wild pig populations in both the southern United States and western United States, as well as in Canada, particularly the prairie provinces, but I think we're learning more where those wild pigs actually are. And then there's an association with the environment or the ecosystem because the virus lives so long in the environment here. So the 4 transmission cycles are very important to this disease. So just a reminder, the soft tick, part of that first transmission cycle, we've got those soft ticks in Africa and Iberian Peninsula, which are maintaining that transmission cycle. Ticks become infected and pass on either transovarially through their eggs, or the larval stages can transmit to each other or transstadially. This species of this genus of tick, the Ornithodorus, I probably can't pronounce that properly. All species of this genus are in fact susceptible. And what I found interesting was that in Canada, we in fact do have several soft tick species, and in Canada, ours are located in southern BC. And there is a wild pig population down in southern BC. So we're setting ourselves up to where we could have a transmission cycle 1 actually set up in Canada in a semi-moderate climate with soft tick and wild pigs down in that region. So obviously the wild swine are another reservoir, but also are domestic if they're not eradicated. But globally, everybody is attempting to eradicate, although I think that's going to be problematic when you start getting into Asian countries. The wild pig populations, though, are outside of Africa, those 3 species of African pigs, they are not resistant at all to this virus. So we give credit to the slow east-west movement of virus in Europe to the movement of the wild pig populations, that they generally move east and west at a very slow rate of somewhere between 3 and 12 kilometers per year is what they're estimating the spread of the virus is in the wild pig population. That's been upwards of 5 kilometers per month in some sources that I've read. And it really varies. It depends on many factors, including kind of the population size and density and range of that wild pig population. And then it jumps into domestic pigs or backyard pigs, depending on the proximity of the wild to the domestic, as well as the biosecurity issues around those areas. Vegetation is very important. One thing to keep in mind is wild pigs love corn. So wherever there's corn grown in great quantities, that typically is where we see lots of wild pigs. Doesn't really stick to us here in Western Canada. I guess canola is a second favorite, is what I understand. And then also hunting activities and regulations play a part in the distribution of wild pigs. And the Europeans have found that if you just bring in hunters and let them shoot, what they'll do is they'll disperse those wild pig populations, and if infected, they'll in fact disperse African swine fever farther and wider. So the rule of thumb when you have an infected wild pig population is lock out your hunters until you get an organized plan to go in and shoot every single last pig there is, because if you miss one, that's 6 more pigs next year at their regular reproductive rates. These wild pigs typically die, high case fatality, so 90 to 100% die. The virus lives and survives in the environment, so it's got high tenacity. And infection of the next wild pig typically comes because a healthy wild pig finds a carcass and then disturbs it by rooting or consumes it through cannibalism, and then itself becomes infected. So the cycle then continues on. The long distance transmission, though, is due to anthropogenic factors. So this will be either moving infected pigs around the world. This is a picture of the Chinese producer taking his pigs to the wet market, which happens on a regular basis, or it can be through meat product. This would be potentially the biggest risk to North America, is bringing in those infected Polish sausages that we love so much. Or it could be garbage that's dumped off a ship or an airplane that ends up in our pig farm, and that's why most countries have banned swill feeding. The virus survives for weeks to months in cured product, so hence this is a problem. In frozen product for years, it's resistant to salting and curing, and obviously cultural practices and biosecurity play a big role in this disease. So this is the global emergence picture as we now understand it. So we've got this sleepy cycle here of wild pigs and ticks that is in happy harmony, occasional spillover either from ticks into domestic pigs or wild pigs into domestic pigs. But as long as that stayed within Africa, everybody was pretty happy. We had this genotype 1 incursion to Western Europe and then over into Latin and South America. That was caused by contaminated pork products, and then all those countries eradicated with the exception of Sardinia. And then in 2007, we had a genotype 2 incursion in humans to the Republic of Georgia, and then made its way into Europe, Eastern Europe initially. It's now moving its way from east to west, so it's sitting on the German border. We'll talk about that. In fact, it's crossed into Germany recently. And then these long distance jumps. So Belgium became infected a couple of years ago through garbage that was related to truckers that were making their way from east to west and had to have barbecue on a Saturday evening because they can't truck on a Sunday. And then pigs got into their garbage. It's moved also into Russia. Presumably it's something with pork or pigs that have made it jump into China or allowed it to jump into China, and then further jumps into other parts of Southeast Asia. So at this point in time, it's only North America and Australia and New Zealand that are in fact free of African swine fever. These are global distribution maps. The OIE produces these maps, but have changed them in the last year or so, so I can't get a further update yet. But this is what the global map for swine fever looked like in 2006. This picture here in the bottom right, and green is good. So green means never had the disease in your country or have had it and have since eliminated it. And this is the picture as of June 2019, and today it's not going to look much different than that. Lots of red, lots of color, meaning that these are infected parts of the world. So it has dramatically changed in the last 10 to 15 years. This is the current picture in Eastern Europe. So this is Romania. Red dots indicate the domestic swine population. Blue dots represent the wild swine population. And you can see this ring here along the east-west European border, where we have lots of wild swine that are in fact infected. And this is as of last Friday, so March the 26th. The inset I've got here shows this region right here, which is Western Poland and Eastern Germany, and outbreaks here in wild swine represented in these yellow dots in Poland, and opposing them are these 3 to 4 areas in Eastern Germany that now have confirmed positive outbreaks in their wild pig population. And that's been about the last 6 months to a year since Germany has been positive. It's still not in their domestic swine population yet, but the consequences are the same in Germany, that trade has stopped and the industry is in turmoil. So kind of take note. The same would happen in Canada. Even if our wild swine population became infected, our borders would slam shut in a minute. So what we typically have taught our vet students over the years is an outbreak is going to have high mortality and very unusual clinical signs, and clearly, as long as you're not sleeping, you would be able to detect those things, and your response is to contact CFIA and don't leave the farm. And that has been the dogma of most of our foreign animal disease lectures over the last 20 years. But there are several reasons why that, in fact, may not be the case for African swine fever. So the major reason is depicted in this slide, if you can imagine it. So I'll take you through this slowly. Pretend we have a pen or a farm of pigs that has 100 animals in it, and we have one animal here represented by the red dot that becomes infected. With some diseases, such as, in this case, foot and mouth disease, which would be another foreign animal disease for us, we would have 100% of pigs infected in a very short period of time. Mortality, however, would be very low, but we would have a lot of sick pigs with blisters that would be showing clinical signs, and we would certainly, if we saw that in a farm, it would register with us that this is an unusual clinical situation. Although mortality is not high, we would respond appropriately. And that's what we used to think would happen with African swine fever. But in fact, what happens with African swine fever is that of those 100 pigs in the pen, only 10 would become infected. So here's our index pig. The black pigs represent, or black dots represent those are affected. So 10% prevalence, but of those 10 pigs that are infected, 9 out of 10 will die. And if you had 1 million pigs on a farm, that would be a lot of pigs dying. The problem is, if you have a slow spread of this disease, you never reach this threshold to say, I have a huge mortality outbreak. It's a pig dying here and there in the early stages of disease until it kind of exponentially grows. And because it's such a slow spread, initially, it's not picked up early enough. And then during the period where there are infected pigs in the farm, but we're not responding, it's a risk to other units. So high case fatality, meaning infected pigs die, but not many of them because the infection has not spread. And really the reasons for that is an inefficient transmission by the oral nasal route. Remember that it needed that soft tick in Africa to actually spread between individual animals. And in Europe, in the wild boar population, it needs a healthy boar to come across a sick boar and either nose or root or consume it to actually become infected. Nose to nose is a very inefficient transmission. So we're very unlikely to detect this with a passive surveillance system. And just case in point, this is some data from 26 farms in Estonia that were infected in Eastern Europe. And in this table 5 here, I'm showing in the center of the slide, it shows what were the clinical signs that were detected in these farms, during the early stages of the outbreak. And if you go down this list, there's nothing here except for a couple that come up. But the first one, loss of appetite, listlessness, sudden death without prior signs. That happens every day on some of our farms. This one's unique. skin hemorrhages or cyanosis, and we showed you some pictures of that. So that was in 11 out of 26, less than 50% of farms. Then we have fever recumbency. Well, that happens every day. Incoordination in a small number of farms. So that may be something that an astute producer would pick up. And then the others are abortions and respiratory disorders. So the clinical signs are not particularly unique to this disease without, except for the skin hemorrhages and cyanosis and incoordination. And then in this bottom chart, the data is broken down by farm. So by farm size from G1 to G4, which is basically small farm to big farm. And this is the overall effect on mortality in the farm. So averaging small farms fairly high at 25 to 30%, large farms very, very low at less than 1%. And then this is the mortality in affected groups. And even in these small farms, it's high, but it's not excessively high. And a lot of these farms, in fact, are very, very low, fall way below an intervention threshold that we would set in the farm to say, this is really unusual. So this period from when the first animal is infected to when the herd is diagnosed is called the high-risk period, because this is the time when it can spread without that farm being shut and locked down. And you can see this is the data spread out by days. About half of the farms detected clinical signs and then were diagnosed within 10 days. But we had a small number of farms out here that took 2 to 3 weeks to be detected. And during that period, then those farms are operating normally, sending pigs to slaughter. Probably visitation is limited, but there could be dead stock removal, or there could be feed trucks coming onto farm. Lots of opportunity for that virus to spread. And if it's a multiplier or a nucleus farm, they could in fact be selling live pigs out to other farms. So what are the risks to the North American industry? Well, I think the first comment is, if you know anything about pig industries, or the pig industry in Western Canada particularly, but across Canada, and it's really integrated with the US market. And I call it bi-directional here. There are a few pigs coming from the US into Canada, but for the most part, we are shipping pigs down to the US by the thousands, and that's coming out of Manitoba, out of Alberta, out of Ontario, and those are going down trucks daily. So what we have here, they are certainly at risk of picking up. And we also have wild boar populations in our countries as well. So we have good controls through CFIA, but still our risks potentially are through infected animals that are imported into the country, or germplasm. One would hope CFIA has that under control. Contaminated meat products would obviously be the issue, and that could be meat brought up by visitors, or it could be through garbage or byproducts that make it into the black meat trade, and there's lots of black market for trade in this country. This is a picture, you may remember this from a couple of years ago, of Hardy the beagle at Atlanta, finding this head in the luggage of an Ecuadorian visitor. Ecuador is free of African swine fever, but if that had been from Asia, I think we'd be a lot more concerned. Other meat products, obviously, and then the other that's raising more red flags now is through imported feed ingredients, and that came out of the PED outbreaks, where we recognized that it was probably feed ingredients that brought PED from Asia, China specifically, into the country. In Canada, we have 3 different pig compartments. We have our commercial sector here, 1.2 million sows, 27 million pigs, give or take a few million, largely split between east and west. We have small backyard or small scale production, and we have our wild pigs in 3 separate compartments. With respect to our small scale or backyard farms, we have close to 5,500 backyard farms that are spread across the country. And we have about 7,500 commercial farms or domestic intensive farms across the country as well. So just about as many backyard small producers as we do have large commercial producers. So small scale production, many in the industry think that this is likely where the source of infection would come. And that's for several reasons. One is just a lack of understanding of the ASF urgency, particularly as you get into small numbers of pigs in urban centers for own use. There typically is lack of veterinary care or a loose relationship, and certainly not a valid client-patient relationship here that's required for dispensing of prescription products. There's lots of historical importation of non-traditional breeds. There's probably poor biosecurity compared to our large domestic farms. And things like the ban on swill feeding may not be observed because in the backyard, or particularly the urban type of backyard production, they see that as recycling food waste as a good thing, where the rest of us say that's an illegal activity and it needs to be banned. And also with outside production in general, which typically is in our small scale production, there's greater access to wildlife and wild pigs if there was a break in that population. And speaking of wild pigs, here's our map of USA from a couple of years ago. The purple represents the wild pigs that are largely distributed in the west or the southern United States, and then along the eastern or the western seaboard here, with individual counties or states affected elsewhere, largely because of hunting farms that have been set up in these individual states. The exception may be these up in this area, but particularly this one here, which matches this population that we see in the southern prairies, particularly in southern Saskatchewan, which gets the prize for the most dense population of wild pigs in the country, and how it has grown since the 1990s to 2000s, when we had very few wild pigs. So thanks to our Canadian producers here in the West, we have certainly fostered a wild pig population, which is a mixture of imported Eurasian as well as domestic pigs that have escaped or broken out of facilities. So when wild boars became infected in Eastern Europe, the experts at that time, back 10 years ago, would have said the wild boar population will be wiped out by African swine fever. Kind of like, oh, well, we'll check 2 boxes off at one time, get rid of African swine fever and the wild boars. But unfortunately, pigs prove them wrong, like pigs normally do. And we have this endemically infected wild boar population. And there's an ecology that goes along with that. And that's what the Europeans are now calling the persistence triangle, and is something that I caution Canadians about, because this could in fact happen in Canada or the US. So the factors are this high tenacity. This virus lives for a long time in the environment. So if you have a dead carcass that's broken open, then you've got that virus leaching into the soil that can survive there for a long time. Freezing in Canada is not going to get rid of the virus. Freezing typically preserves viruses, so that is not in our favor. The other thing is it has a low has a high case fatality rate. So it kills those infected animals. So they are hunting normally, doing their thing. They become infected. They go back to their den and they die. 90% of them will in fact die, leaving that carcass available for the next pig to come along and disturb or consume. So there's always a source of virus. And then what's most important here is that it has very slow spread. It's lowly contagious, so it never depletes the entire wild boar population. So in the process of killing these pigs one at a time, there's always a carcass that another pig can come to. That carcass can then wander to its own home den and then continue on. So there's lots of opportunity for this virus to spread once it gets into the wild boar population. So if we had a break in any one of these sectors, wild pigs or the backyard small scale production or in domestic, what's the impact? Well, the first thing is immediate closure of all of our borders to trade. And we now export over 50%, estimates are 60 to 70%. We are not going to eat our way out of a border closure. So that means we have domestic pigs which are backing up. The infected farms would be taken under the auspices of CFIA and would be eliminated. And there would be zones put around those areas. The infected farms would be CFIA compensated, and they would be looked after. But the real impact of this disease is in fact on the non-affected farms that are affected by the border closure, not necessarily the disease itself. So those farms would start to overcrowd, and they would maybe be able to store an extra couple of weeks of pigs by doubling up on pens. They've got 40 more weeks of production in the pipeline if they're a farrow to finish farm. So everything you bred last week will farrow over the next 17 weeks, and then there's 26 weeks of production as they move their way up to the finishing floor. We would have to euthanize pigs because if they can't go to slaughter, there's no place for them. We have to figure out how to dispose of these carcasses. There's simply not enough captive bullets or bullets in the world or carbon dioxide to euthanize these. So we have to figure out how to kill them, how to dispose of them. They probably would end up digging pits and putting them in pits on farm. And then we have a severe liquidity or solvency crisis on farms, particularly as our banks start to draw on their loans or their operating lines of credit to pay for feed. So we have a serious issue. Over time, CFIA would zone and hopefully open up some parts of the country. And then there is a movement in Canada to try to compartmentalize certain areas of the country, or certainly operating systems. So Maple Leaf has an initiative to kind of compartmentalize their slaughter plant and all the suppliers so that they can maintain some flow, after people are comfortable with the status of the country. So bottom line is, I think the swine industry in this country would be really under severe financial stress and probably would implode like it has in most other countries. There is a bright light, and that's vaccines, and it's certainly not a bright light at this point in time, it's more of a dim light. But there have been no shortage of people trying to get vaccines developed and registered here, and there is some success. So as a general rule, inactivated vaccines don't work. So that's where you grow the virus up, you kill it, and you inject it. So that's not going to work. Subunit vaccines, where we figure out what proteins are virulent and make a vaccine specifically for those proteins, they're far safer. But those have been tried, and quote from a paper I read, those are far from reality. And that leaves us with attenuated live vaccines. And there are a number of attenuated live vaccines on the market that have originated in vitro through passage on cell lines, or going in specifically looking at a gene and deleting that gene, or sometimes just field isolates that are not very virulent. And there's always a risk and a safety concern of attenuated live vaccines because they could revert to virulence. But that being said, this is the, most promising development we have. We want them to be safe. We want to be able to differentiate the vaccine strain from the wild strain. We like them to be cross-protective. We want them to be able to be used for wildlife immunization strategies, so potentially using them orally. And obviously, we need to be able to mass produce them in any manufacturing plant that's around. Several have been tried. The one that's showing the most promise is this USDA Delta 177 strain, which they have developed. It's got good sterilizing immunity, and it's now being beta tested in Vietnam for the genotype 2 strain. So I guess we'll wait for word to come on how effective that is, but we are keeping our fingers crossed. So just to finish up, really thank you for the opportunity to speak to you. But I hope my messages are clear. Please do your part. Please be aware of the risks of African swine fever in pigs, and please do what you can to keep our Canadian pigs healthy and safe. And thanks very much. I'd be happy to answer any questions.
Thanks, John. Fascinating and terrifying discussion. And now I'm regretting my lunch choice of Smokies, but very, very interesting. There was a question in the chat about movement of pigs to slaughter, and I think the potential interaction for ticks with that. But I think you've kind of explained that the tick interaction with the disease is with the wild population. Am I getting that right?
Yeah, that's right. The tick is the reservoir for the wild population more than the domestic pigs. Of course, if domestic pigs become infected with ticks, it'd be a problem as well. But I think the domestic population, let's largely assume that that's inside. There's less likelihood of a tick infestation there. It's more the wild swine or backyard swine that has wildlife and tick access. And that's only where ticks would live. The only place I've seen in Canada is this southern BC region.
And I think one of the other questions I thought would be useful for our group to kind of discuss is, as you know, professional agrologists are involved in all the different aspects of swine production in the province, with feed production, care for animals, and then also on the wild boar end of things, they're looking at imagining them as an invasive species that to manage on those lands. How do you see professional agrologists fitting into the kind of preparing for the coming of the disease, or reducing the potential for the disease to come to Canada?
Yeah, so that would be involvement through one of the provincial pork boards, yeah, across the prairie provinces or in any province, as well as through CPC and the government of Canada, if any members are government employees. But there are different task force and groups that have been set up to cover the different aspects of planning and preparedness. So, you know, some of those are euthanasia, some of those are disposal, some of those are communication and border security. Wild pigs are part of that as well. So I think as far as preparedness, I think the groups are out there and are working hard now. So I would think that professional agrologists, if not involved in those aspects now, your biggest involvement is probably through feed ingredients. So looking at risk of contamination from imported ingredients, so be aware of what is coming in from China. There is research now to explain how many days African swine fever has the potential to live on some feedstuffs, as well as mitigation measures to not sterilize feed, but to inactivate viruses that are on feed, either through hold periods under certain temperatures, or by, you know, the research is coming, but adding some sort of commercial mitigant or inactivating agent. So certainly feed is a big part of it. And as you mentioned, wild pigs are a big part of it. You know, I would like to say we should just eliminate wild pigs, but, you know, I think the pig may be out of the gate by now. It may be too late for that, especially in Saskatchewan.
Yeah, that's a topic I've been following Dr. Ryan Brook on the wild boar and its impact, and so it's one I'm particularly interested in, and also the backyard swine production, as that's my major source of when we're making sausage, it's from our buddy down the road, not from major facilities. So
and that's a very good point. That's a very good point. Those small-scale producers are looking for professional guidance. So, you know, you may be a great contact point for those producers.
Give me an excuse to keep making sausage. A clarification on the question about bringing pigs to slaughter, and whether or not non-infected pig can become infected during transportation to slaughter, resulting in potential outbreak. I suppose it's in that time when the pig is no longer in the secure facility and moving to slaughter. I think that would be.
Yeah, so if we put a pig on a truck at the farm and drive it to the slaughter plant, my guess is the chance is probably low that pig would become infected. It is certainly susceptible, but it would be probably low that it would become infected because there's no real exposure, to be honest. The bigger problem is probably, you know, what's happening at the slaughter plant, because you have so many pigs from so many sources coming in that if you did happen to have an infected one coming in, it then would spread. And as we know, slaughter plants are not cleaned out, so that would then become a source of infection. And we saw that with PED, in fact, with the small assembly yards that are used for shipping sows. That sows were coming in from multiple units, infecting and then being moved off. So PED is an example, and Strep zooepidemicus, the recent outbreak in the last 2 years, it was those slaughter yards shipping cull sows that became the source of infection that, you know, stayed on for a matter of weeks.
I think that clears it up. Thank you, John. I think the other question I was going to ask was about. Well, actually, I want to know if anybody else has any questions. I'd be happy to pepper you, John, with questions for the rest of the afternoon here. But I'll invite questions from the floor as well. If anybody wants to make it known, they can put a question in the chat or put their hand up, virtual hand up, and then unmute themselves. I guess the question I was going to ask, John, is about COVID's on the mind and pandemics are on the mind. Are you finding this is ongoing work? You've said the committees are in place and people are thinking about this now. Are you finding that there is a better understanding of the importance of global spread of diseases that's helping explain what's going on here, or is there a change in context in the last year or so?
There's a change in context since PED broke in North America. So PED, porcine epidemic diarrhea, jumped from China to the US in 2013 and then moved to Canada in 2014, both Ontario, Manitoba. That was the wake-up call. And I think, to be honest, that kind of started the initiation to say, viruses in China are important because they can jump to North America. And then also it woke up the federal government and the swine industry to kind of say, we need to work together to come up with a plan, because we got off easy with PED. Even though we didn't have it, it's not classified as a foreign animal disease, so it didn't shut down borders. African swine fever, foot and mouth disease, or some of the other classic swine fever as an example, they would shut down the border. And now, whether the government wants to, likes it or not, they're going to get involved in this point in time. So I think there's enough push from the Canadian Pork Council, CFIA, and Agriculture, Agri-Food Canada, that they got together and said, let's make a plan and start working our way through it. And that's when those committees came together. That's kind of unprecedented in Canada, certainly in my career, to have this degree of cooperation at those levels. Normally they're poking each other in the eye because nobody's doing enough. Now they are working together.
So you would say, John, that you're feeling pretty confident about our preparedness at this point?
I wouldn't go that far. I would say I'm confident that we have people together identifying gaps and trying to come up with solutions. The issue I've got is, if something happens tomorrow, I think we are still completely unprepared for it. For instance, we don't know how to kill millions and millions of pigs in this country. We don't have the means to do it. It's something that we've been talking about for 30 years, and we still don't have the answer to that. There are people working on it, but we don't have the answer. And when you look at carcass disposal, there are lots of options out there. Probably we would use a bunch of different options to try to deal with individual farms. But if you're the first farm that's infected, you're kind of the lucky one, because CFIA has to deal with you. If you're the second farm, or you're the farm that are affected because the border shut down, it's the swine industry that has to look out for you. And I'm not convinced we've got all the answers. So ultimately, it's the owner operator of that operation that has to have the preparedness plan for his or her own operation. I'm really not sure that we are down to that grassroots level at this point in time, but we need to be.
It sounds like another potential avenue for professional agrologists to be involved in some of that contingency planning. Yeah.
Completely agree.
Dwayne has asked, and I think you spoke to this a bit in your presentation, about the level of export dependency in the swine industry.
50 to 70%. So that means, 1 in 2 animals we produce are exported. A lot of those are exported as isoweans at 3 weeks of age. There are some slaughter hogs, but with cost of transportation, most of those are isoweans or breeding stock. So what we would end up seeing is that border shuts immediately. And Canada and US agreed last week that even if the outbreak is in the wild pig population, the border will in fact slam shut. So, that means that we've got all these thousands of isoweans going down every single week that need to be eliminated.
Yeah.
If there's no nursery to place them in Canada, and there won't be, then they have to be killed. So we're not going to eat our way out of this, which is what that was meant for.
Yeah. Yeah, so you've totally ruined my lunch. Thank you, John. I appreciate that. But fascinating information and very useful, and I think gives us some good context here. We've got one more question before we wrap it up here. So Jacqueline says, I think African swine fever is important to many parts of the agriculture industry in Canada. The global pork industry uses our canola meal since we are ASF free. It's important to keep ASF out of our country for main parts of the agriculture industry here in Canada. So she's just giving you a thanks, and I think giving us that global context is very helpful to better understanding the role that our industry, that our profession plays in ensuring food continues to be safe, and our economies and societies are stable as well. So thanks a lot, John, and thank you for everybody's participation. I'm going to sign off from John and turn it over to Dwayne now for the rest of our day's meeting.